We can investigate reflection using a ray box, and indeed in class you will have had lots of opportunities to do so. We initially start with the plane mirror, and when we place the plane mirror onto our white page, we must mark the point where reflection occurs. And if you can see clearly, this is the glass portion and it's backed onto a piece of aluminium to support it. And where reflection actually occurs is at the very back of the mirror, where it's attached to the glass. So it is important that when we place it on the page, we put a mark at the top where the mirror joins the glass, and at the bottom where the support joins the glass. We then join this up with a ruler. And this shows the surface where the reflection actually occurs. In the exams you will often see this with hatching to show the back of the mirror. So when we're investigating it in the practical, we set the mirror back exactly onto that line again, and we set the ray box so that the light is coming in at an angle to the normal, or an angle to the mirror. For example, this ruler could represent the ray of light. So it's coming into the mirror, and when we have the ray of light coming in, we put some dots along it and some dots along the reflected ray, which will be out in this direction. Then, once we have those dots, we remove the mirror, turn off the ray box, and join up the dots with a pencil and a ruler, remembering, of course, to put an arrow onto it to indicate the direction of travel of the light. Now, if I draw on where I would imagine the reflected ray to be. Now, bearing in mind I haven't done this experiment on video, therefore there will be slight inaccuracies in what I've produced here. This is what we call the incident ray, because it is the one that is incoming to the mirror. It then meets the mirror and is reflected, so this ray is then called the reflected ray. Now, there are some other important factors when we're drawing these diagrams to ensure accuracy. Where the ray meets the mirror, we draw a normal. To draw this normal accurately, you use a protractor and ensure that this angle is 90 degrees. So a normal is a line perpendicular to the surface which is reflecting. And whenever we use a protractor to measure the angles, we should find that this angle is equal to the reflected angle. We call the first angle the angle of incidence, as it is between the incident ray and the normal, and the second one is the angle of reflection. And when we investigate reflection, we will find that no matter what angle we put the incident ray at, we can make it as wide or as narrow as we wish. The angle of reflection is always equal to the angle of incidence. In short, we call the angle of incidence I and the angle of reflection R, and they are equal. It's important that you know that. That would be what we call the law of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. Now, if we were to move the ray box right round so that the light was coming in at 90 degrees to the mirror, it would be reflected right back along the same pathway. Okay, looking at some properties of reflection then. In a plane mirror, the image is the same size as the object. For a plain ordinary flat surface mirror we will find that the image is the same size as the object. The image is the same distance from the mirror as the object. The image is laterally inverted. What do we mean by that? Laterally inverted. This means that left becomes right and right becomes left. We often see this whenever we're looking at emergency vehicles. They use this property to good effect. If we look at the front of an ambulance, the letters are written to our eyes to be back to front. This is so that drivers and rear view mirrors can see when an ambulance comes behind them, they can clearly read the fact that it's an ambulance. Also, the image is virtual. Now we will do some further work in a few slides' time about these properties in terms of the image being the same distance from the mirror as the object and the image is virtual. Not only do you need to know these facts, but you need to be able to prove them with a diagram, which we will look at later. Reflection diagrams. Whenever we did the slide on investigating reflection, we drew what was called a reflection ray diagram. And there are certain key points that you must follow whenever you're drawing these diagrams in the exam. Firstly, the law of reflection states that the angle of incidence is equal to the angle of reflection. You must learn that and be able to state that in exams when asked about the law of reflection. In short, I equals R. You must also be able to use a protractor to measure the angles, either for a diagram that has been given to you, like this one on the right, or whenever you're actually producing a diagram. In some cases you could be given a picture of the mirror with an incident ray and nothing else. So you have to then convert that incident ray and be able to draw the reflected ray correctly and accurately. So you need a protractor to be able to do that. You must always, as we said earlier, use a ruler to draw the rays. So in the case of this diagram, this red arrow refers to the angle of incidence, and the second one refers to the angle of reflection. You should also be able to name the black dotted line. This is the normal. And remember, it's always at perpendicular to the mirror or at 90 degrees. If we looked at this diagram, we should be able to use a protractor then to measure each of the angles, and they should be equal. So in the exam, the angle of incidence equals the angle of reflection. If you were given an incident ray, you should then be able to draw the normal at 90 degrees, measure this angle, then come round the second angle the same number of degrees and draw in your angle of reflection and your reflected ray. This is one aspect you must practice.